Hello and welcome to AVAIRY Forensics free training series. My name is Kevin DeLong. I'm the founder of AVAIRY Forensic Solutions. In today's episode, you're going to learn about how to crack an encrypted iTunes backup utilizing Hashcat. Okay, let's go ahead and get started on this cracking. We're going to utilize a few pieces of software first. We're going to be utilizing Hashcat. That's going to do the primary work for us. That's the open source software. I'm going to show you here in just a little bit on how to crack that software or crack that iTunes backup. And we're going to be working with iOS 9 and iOS 10. So we can do both, even the current version of iOS as of the making of this video that we can crack. We need a couple key pieces of information, however. We need the Manifest.plist in the backup file contained within the root of the backup. So to do that, we need to locate that. So here we go. So the iOS backup location is under Windows. If you're examining a Windows machine, it's probably going to be on the C drive. I didn't put C on here. Just so you can, hopefully it's on the C. They may have moved it, but regardless, normally on the C drive under the users, whoever the logged in user in, or there might be multiple users on that machine. AppData, roaming, Apple computer, MobileSync, and then backup. And that's going to be the root of the backups. Then you'll have to go into the individual backup folder itself to find the manifest file. Okay, and it's just Manifest.plist, and I'll probably show you here on this one. I'm on a Mac to show you exactly where it's at. And then obviously on the back, we go to the logged in user right here. That's what the tilde means. Under library, application support, MobileSync, and then backup. Okay, so as you've seen here, I've gone ahead and opened up a Finder window in Mac. Windows, it'll be Windows Explorer. Or Explorer, whatever they're calling it now. I'm not a big Windows user. So here I'm going to navigate just to show you where it's at into my Mac hard drive. Under Users, my name right there. Then I'm going to go to Library, Application Support that you can see here, MobileSync, and then Backups. And you can see right here, these were all my backups. Are going to be living. You can see I have a few iOS devices backed up here. Now I want to show you something here. This one, you can see in this backup here that this is the new style of iOS backup, how they're doing this in the folders. Okay, and they're keeping files within the folders here. Okay, here is the old style where they're just throwing them all into the root directory. Either way, it doesn't matter because the Manifest.plist, let me grab this, all the way to the bottom normally. Right there is the file that we need. So this is the file that we need for the Manifest.plist in the old style of backup. And the new style of backup is no different. It is right there under the Manifest.plist. So now that we have those two files, I'm going to name them. I'm pulling them out of here. I'm going to name them because one is from the current version of iOS, which is 10.3.1, sorry. And the other one is a 9.3.5, which was the last version of 9, I believe they made, or at least the last one that my older iPad happened to support. So let's go ahead and take a look at these in a different way. Okay, before we take a look at those, the files themselves, what I want you to do is to make sure that you get a copy of Hashcat. All right, so here is the website. It's hashcat.net /Hashcat. You can just Google it as well. Don't ever trust my URLs. Go through, check it out, and you can go ahead and download it for your operating system. Okay, it'll run off of a few different ones. Linux, obviously Mac it runs on, and of course it runs on Windows as well. Now what you're going to want to do here, and I'm going to kind of get this out of the way ahead of time, is that Hashcat utilizes the GPU, or the graphics processing unit, on your system. So if you're going to really do this for cases, and it's obviously something you're going to take to trial or something that you need to prove, and you absolutely need the passwords or a faster way to do this. Get build a system up that will actually have a decent graphics card in here. What I'm using now is a Mac, literally from 2012. Now it's not terrible. It gets passwords and it's not horrific at it, but it is an older system with the NVIDIA style of graphics card in here, which I'll show you that a little bit later on. So if any questions you have about Hashcat, here's where you can find them. You can go to the forums. The wiki is just a wealth of information here for Hashcat. So it gives you all the commands. If you're not a command line person, you're going to learn a little bit here or in this video. But I'm also going to suggest that you go here, do a little bit of homework on Hashcat. It's really simple to use. I picked it up pretty easily. Anyway, that's what I want to show you is the hashcat.net. Go ahead and check that out so you're aware of it. So we need some pieces of information because Hashcat needs key pieces from that Manifest.plist in a certain order and laid out in a certain way. So I need to show you how to do that. So let's slide over here to the next screen that I have open. Now, I have one of the Manifest.plist, and you can see right here, I've renamed this. This is just Text Wrangler on Mac, which is a free piece of software that actually will read and it understands plists on how they're laid out. But you can utilize anything on Windows. There's plist Explorer. There's all sorts of different things that you can look, and probably whatever forensic software you're using will also, or hopefully, will parse open a plist. But you don't need necessarily something that opens a plist. I'm going to show you a different alternative as well. So this screen back here that I've just hidden from you and just brought back is the style, it is the style that Hashcat requires. Now, Hashcat will crack iOS 10, the current version, and it will crack, obviously, older styles as well. But Apple changed the encryption algorithms or made it a little bit more complex in, I think it was iOS 10.2.1, I believe, was the one that they did it in. I'm not exactly sure on that. I have to check to be certain. So they require different ways. So in just a plain text document, if we're cracking iOS 9 or older, now I say less than iOS 10 here. I know that's kind of weird, and I should be saying 9 or older. But Hashcat says that on their wiki site. So what I mean by that is the attack vector that you're going to utilize, and I'm going to see if I can go there and find this for you here really quick as we go through, as I'm talking to you, that you need the proper algorithm in order to do that. And right here it is. I don't know how well you can see that or not. And that's the way I put it that way, is because they say, hey, if you're going to crack an iTunes backup that's less than 10, or the backup that's greater than or equal to 10. That's why I said it that way, because this is the way that Hashcat does it on their website, and there's a certain code that you need in order to crack that. And I'm going to show you what that is. So that's why I put it this way. So if we're going to go after a version 9 or older, we need some key pieces of information. And literally, this is the only thing that will be in a plain text document. All right, so you need this right there. You need the $, and then iTunes _backup $, and you do need the asterisk. You do need this asterisk in here as well. Then we need the version. Now, anything you see in brackets here, or these carets, sideways carets, greater than, less than symbols, there's a proper term for them, and I can't remember what that is for the life of me right now. That is going to be replaced with actual data. So we need the version. Now, obviously, if we're going to go after an iTunes backup here, I don't think you're going to come across iOS 8. You might, or older than that. It's possible, but usually you're going to look 9, 10, and 9. I think it's going to be even rougher to find as everybody in Apple seems to update their device. Then we're going to need the key. All right. Then we're going to need the ITER, which I think stands for iteration, I believe, or iteration times. Yeah, something like that. And then also we're going to need the salt. We're going to need the salt as well. And I'm going to show you where all to find that, all within that Manifest.plist file. Okay. So here I have I'm going to start with version 9. We have 9.3.5 open. And it's pretty easy to tell what version of iTunes that I'm utilizing here, right? So if you're looking at this in a plist viewer, this is the way that it's going to be displayed to you, all right? So you can see it came from a very old iPad, which is my iPad here. And then you can see right here that yes, indeed, the backup is encrypted. So this is important. Obviously, if it is not encrypted, we don't need to even bother with any of this process. But if it is encrypted, here's the data of the backup key bag that we're going to need in order to crack that this backup file. All of this data right here is in base 64, so you can take this out and convert it from base 64 to standard ASCII and go ahead and read all of this stuff. Or what you can do is open up your favorite hex editor. I'm going to use, what is this? I think it's Hex Workshop here. And I'm going to go ahead and open up that manifest file. And I've gone ahead, and you can see right here that I've gone ahead and labeled these. Normally it's just Manifest.plist, but I've gone ahead and put the version of iOS after it, so I know, obviously for demonstration purposes, which one I'm opening. I'm going to go open this 935. Let's go ahead and open that up. And you can see that it's a binary plist based off of the header that we have here. And we need those key pieces of information. Let me go back and refer back to this. So first of all, we need the version. Well, we have the version, and what I'm going to do here is just type this in here as we go. So it's version 9. You don't have to put the point values. Round it to its solid down number, right? So if it's 9.1, 2, 3, 4, whatever, it's always going to be version 9. We don't have to put any of the point values in there. So I'm going to skip a couple lines just to kind of keep this tidy as I can and come back over here. Oh, let me see what I need next. I need the key. I need the WPKY. Now this is going to be a little bit confusing for you because if we go here to File, Edit, and we go to Find, and I already had it in here obviously, WPKY, let's go ahead and hit OK. We have found a bunch of them, 11 of them to be exact. We don't need all 11 of these. All we need is the one closest to the top of this, which where you see right here is a UUID. That's what we need. So I'm going to go ahead and take a look at this. I'm going to get rid of these highlights right there. And you can see I have a WPKY right there. It's telling me what it is. This is the header, essentially, for the key. It's like, okay, now where is the key and how many do I need to grab? So what Apple does here is they take the next 4 bytes read in Big Endian, which means we're reading from left to right, the most significant value over, or the most significant bit, Big Endian here, and we're reading across, so it's 00000028 hexadecimal, right? So since all these are zeros and we're dealing in Big Endian, you can look right over here. It converted the 28 over to 40. So 40 bytes is how long the key is that we need to grab. So 4 bytes show us that. So I'm going to go ahead and highlight right here, and I'm going to highlight 40 bytes, which is right there. So 40 bytes, I can tell that I have 40 because down here I have a selection of 40, and whatever hex you're using or forensic software that you're using, hopefully it's going to show you what you have. I'm going to bookmark this information just so I have it, and I'm going to call this the WPKY data that I need, and I'm going to leave it as a blob because that's the style I need it in. So go ahead and bookmark that. All right, let's slide back over here and see what else I need. I need the ITER, the iterations. Okay, so what we're going to do is from here, we're going to try to work up from that WPKY. We don't want anything down here because you can see it's putting some other information on it, and I haven't reverse engineered any of this, so I'm not sure what that is, so I'm not even going to claim to know. But I can see right here, I have the ITER. There is the header, ITER of information. So again, we're going to grab the next 4 bytes of information here, 4 bytes, and that is going to tell me how much data I need. Well, is the number 4 there, right? So I need 4 bytes of data, and we can look over here at the interpreter and see that, hey, yep, there it is. Data inspector says there's 4 bytes. So I'm going to grab 4 bytes of information. So there's my 4 bytes of data and information here. So I'm going to move the mic just a little bit so I can get some better audio out of this. And that tells me 10,000. 10,000. So I'm going to bookmark this data here, add this bookmark. And this is the ITER data. And is it going to be a blob? Nope. It is going to be signed and long. So in the big Indian order. So I'm going to go ahead and take that. You can see down here that I've bookmarked that. And now I have it. All right. So the next thing that I need, let's slide over here and take a look. So for anything that's iOS 9, which we're working on, we need the salt now. So we're going to go ahead and take a look at the salt. Well, we can see the header real clear because it's in ASCII. All right, salt. And then it holds true again, big Indian style. We're going to grab 4 bytes of information, and this is going to tell me how long that the salt is. And obviously 14, for those of you that are hex gurus, are 20. I'm going to use this over here because my brain does not like to process hex for whatever reason. So I need to grab 20 bytes, the next 20 bytes of information, which should be right there. It is indeed. So I'm going to bookmark this. I'm going to go ahead and say add bookmark. And this is my salt data. So I have that. I'm going to leave that in blob format. So now I have all my key pieces of information that I need to satisfy this. So I have the WPKY. So let's go ahead and take a look at the WPKY one, which is right here. I'm going to click that bookmark, and it's going to highlight all of my data. So I'm going to make sure I have all of that highlighted, and I'm going to copy that hex. I'm going to go over here to my Word document or my text document that I have open, and I'm going to paste that right in. And let's open this up a little bit so it's one continuous line. So I have that. And then I'm going to skip down a couple more lines. And then I need the ITER, the iterations that we have here. So that's pretty easy. So that's 10,000. So I'm just going to copy that right from there and put that in there. And I'm going to skip down 2 more. And the last thing that I need is the salt. So I'm just going to go re-highlight all the salt. Oops. And let's try to highlight that correctly. Copy that out. And then I'm going to paste the salt right in there. So those are the 3 key pieces of information that we need. So let's start replacing this chart with what exactly we need and how it's going to look. So I'm going to go ahead and I'm going to open up a new text document here, and I'm going to paste this in here. I'm going to try to also make this a little bit larger for you so we're not struggling to see. There we go. So we can see this thing. And I'm going to stretch this out the same length of what we've been working with. And I'm just going to replace these values. So version here we know is 9. I don't need to copy and paste that. It's 1 character. I can handle that. Then what we need is this WPKY. I'm going to go ahead and copy that out here. And I'm going to just hover right over all these brackets, highlight that, and just paste them right in there. So there's what we need there. And then I need the ITER. So copy that one. And ITER, oops, I need to include these brackets too. Paste that right in there. And then the last thing I need here is the salt. So I'm going to copy the salt out, and I'm going to go in here and paste it. And yes, there are 2 asterisks at the end of this. There are 2 asterisks at the end of this. So then you simply rename this file to whatever it is that you're going to go after. In our case, it's the Manifest 935, and you can leave it a .txt file. That's absolutely fine to do that. So what you'll do is rename this. Let's go ahead and say this is a Manifest 9.3.5. And I'll leave that as a text is perfectly fine, or we can take the text off. It doesn't matter regardless. So then we'll show you the next step here of what you're going to need to do when you take this into Hashcat. Okay, so now that we have all of the key pieces of information that we need from an iOS 9 encrypted backup out of the Manifest.plist file. I'm going to show you an easier way that you can get it. I know I showed you the difficult way first, but those of you who have ever had me in a class before know, and it's important that you know, where exactly all of that information is coming from. So that's why we did it the hard way first. Now let's do it the easy way. And we're going to do that from this website right here that I'm showing you. So you can just pause this video and write down this website. I may put it in the notes below in the video or not. I'm not really sure, but you can take this website right here and it's going to take you right here. Okay, so once you get here, this is a Perl script. This is what this .pl means down here. It's a Perl script that's going to run, and you can run it against the Manifest.plist file. And when you run it against that file, it pulls out all of the information that you need and formats it in the way that you need it to run it in Hashcat. So it'll make it look just like this right here. You can see this is the one that we did manually, if you remember. This is the one that we pulled out each stage of information just a little bit ago. 9, you know, we pulled out the key, we pulled out the iteration, we pulled out the salt, and we put it all in here. Now watch what happens right here. So I'm going to go ahead and issue this iTunes against the Manifest, and I think I called this 9.3.5.plist, right? 9.5.3, 9.3.5. 3.5.plist. There we go. That's what you hear, these little bells in there. It's me mistyping things. And watch what happens here. Ta-da! See so what it does? I know, right? Dirty that I show it you that way. But at least you have an understanding of where it's coming from. And if you do need to explain it to court, that's truly what makes you a forensic expert, right? Is knowing where these things come from. Don't rely on a button to do that for you. So it grabbed out. Let's just see if it grabbed out the exact same thing. So I'm just going to check the first 5, right? So I got 1649D. Let's slide over here. I got 1649D. All right, let's check the last little bit here. It ends in D. Face, I think I remember it spelling in face. It spelled that there. 10,000 is the iteration here in 10,000. And then A66EF. Let's take a look. A66EF. Again, everything is identical, so you can go ahead and verify that information. That little script is handy. It helps pull out that information for you. Okay, so let's get to cracking this thing. I'm gonna go ahead and clear my screen so we can get rid of all that other stuff that makes it so much easier, that script. So what I need to do now is I've moved that file that we created right here, this manifest 9.3.5.text over to the directory I'm working in. I'm gonna go ahead and see if I can't find that little file here. Where did it go? Manifest. There it is, right there. 9.3.5.text. So this contains just the information that we need for Hashcat to go ahead and crack this passcode for me. So what I'm going to do is enter. You're going to hear these little bells again. I apologize for that. We're going to enter some information, the command for Hashcat to go ahead and start working on this file. So obviously I'm going to start Hashcat here, and then I need to tell it what mode I need it to go in. So there's 2 modes that we're going to be working with here. The first one for iOS 9 is going to be 14700. All right, and these can be found on the Hashcat forums and the Hashcat website. But that's the mode that we're going to utilize. And then we need to tell it what file that we're going after. Well, it's the manifest 9.3.5.txt, if you remember. We don't want to go after the plist, right? Because it doesn't know what to do with all that information. The text file is where we condense that down to. So there we have that, and now we have to specify what type of attack that we're going after. If you have a dictionary, which I would highly recommend if you're on examining a device, or you have any information about the person you're going after, or trying to break the password, is to create some type of dictionary first. Obviously, that's going to be the best type to utilize, and most forensic software do that if you're examining more than just a phone. right? Maybe the computer that you got the iTunes backup from, you're going to create a dictionary out of that, and you can do that multiple ways. So I'm going to go ahead and just use a brute force on this, right? Not the way that you would normally do this, but I'm going to tell it to attack mode 3. Now this is a mask / brute force. With the newest version of Hashcat, it works a little bit differently. We're not going to get into all of that, but that's what I'm going to utilize. Then I want to specify what type of digits, or what am I going to go after? Am I going to go after uppercase, lowercase, special characters, or am I going to go after numbers only? Well, I can tell you, I'm going to show you this. This is going to be a simple one. This is numbers only. So I'm going to make my first list here. That's a 1 that I typed. I'm going to make it actually, I'm not going to even create a list here. I just need to create a mask as to what it is. So I need to guess a digit, a digit, a digit, and another digit. All right. 4 digits is what I suspect this one to be, which it is. I created it. So we're going to go after that. Now, obviously, if there's uppercase, we'd work this a little bit differently. But I'm just going to show you that we can go ahead and do this. It's going to recognize all the things that I have, and obviously it recognized that, hey, it's not even a real workload for this particular computer. And what do you want to do for this? Oh, I got a little error there. So let's go ahead and try that again. And this time, I'm going to specify to use device number 3. And let me show you what I'm doing here in case you get this error here. I have 2 graphic cards in this Mac. I have this HD Graphics 4000 and then the GeForce GT 650M. Again, I told you it's a little bit of an older computer, but this older graphics card sometimes causes me some grief. So what I'm telling Hashcat is to use only device 3 here. So I'm going to go ahead and try that one more time. And you can see that it went through there and bam, it got it already. 1, 2, 3, 4. And that is indeed the backup password for that. So now I can decrypt that backup password utilizing 1, 2, 3, 4. Okay, for the sake of time here, we're going to go quickly through iOS 10. We need additional pieces of information here. You can see it. I've moved over back to what I need. Not only do I need the version, which we know is going to be 10 here, but I need the WPK. Why? I need the ITER, I need the SALT, but Apple added 2 more pieces of information that we need called the DPIC and then the DPSL. Now, what I've done right over here is I've gone ahead and I've loaded a manifest from iOS 10. All right, from iOS 10. This is actually 10.3.1 or something like that, I believe. We can find out here in just a minute. But I need you to take a look at the information. So here we have the SALT, right? We have the ITER. Then here is the DPSL and the DPIC. Okay, remember, after these headers, we grab 4, and it tells us how much information that we need to grab. Those 4 bytes immediately after that header of the item will tell us how many bytes it is. So these 4 bytes, we need these. Okay, we need these 4 bytes of information, and this is like what, 1 million, something like that. And then the DPSL, I'm going to grab 4 bytes after that, and it tells me I need 20 characters here. So I just grab 20 characters right there, and I bring this in. Okay, again, we bring it in into the same format as we did this one, and we just fill it in here. And I know some of you are going to ask, hey, does that script work on iOS 10? Absolutely does. And if I quit making that dinging sound, I will show you. So I'm going to show you here by the manifest 10.3.1. I'm going to go ahead and hit that, and you can see that it goes and fills it in with 10. Again, no point values. There's the key that I need. The iteration that I need is in there. What else is in here that I need? There's the SALT. There is the, I can never remember what these things are. I should refer back to it. The DPIC, and then also the DPSL is immediately after that. So what we would do is we would take these, this and create our own text file out of that. Okay, so let's go ahead and do that. I'm going to highlight all of this information that we have here for the iOS 10, and you can see here that it came from the 10.3.1, which as of this recording is the current version of iOS. I'm going to copy this information, and I'm going to create a new file here. So I'm going to go to text edit, file, give me a new one, and I'm going to paste this information right in there. And I believe I need an asterisk at the end. Nope, I don't need anything at the end of this one based off of how it's laid out. So I'm going to change the name here. You can see here, I'm going to change this to Manifest 10.3.1 .text, and I'm going to put this down into the Hashcat library where we're working right now. So there it is. So let's slide over here, and I'm going to go ahead and make sure that file is indeed there. There we see it right there. So let's issue this command. So in this case, what I'm going to do is I'm going to issue the Hashcat command, and I'm going to tell it that I need to, if you remember, I'm going to limit this to device number 3. First off, because we had some issues with that device number 2. And then I'm going to tell it the mode 14800, which we're going to tell it that means iOS 10 and above, if you remember that's what we're going to do. And then again, I would highly recommend getting a dictionary attack, creating a dictionary, building a dictionary, and going that way. But we're going to brute force this. And again, I'm going to tell it the masks. I could use lowercase here. I could use uppercase here. I could use special characters. But I know these are digits. So I'm going to, create a 4 character digit here because I know that's what it is and I created it. I'm going to go ahead and hit go on this, and I didn't load any hashes because I absolutely forgot to do that. So let's tell it that we need to load that manifest file to do that, right? Sure, I guess we need something in here to load. So 10.3.1.txt. There, now we can actually try to go and attack that. I can't believe I forgot that. So there it is. And that's the hash that we need to attack, and away it goes. So you can see here that I'm going to slide up while this is working. It skipped this graphics card too because I told it to, and to only utilize my GT 650. So there we go. We have that, and let's check the status of it. It's running now. I tell you what Apple did in iOS 10 and their backups, they made it very, very challenging. So I'm going to go ahead and pause this video until this completes, because it is going to take a little while, even though it's a very simple code to break. The brute force to run each one of these against the multi-level of algorithms that Apple put in there does take a long time to do. So keep that in mind, that it will eventually get this, and we'll show you that when we come back. Okay, and through the power of editing, we are back. You can see here that Hashcat did indeed crack the encryption of the iTunes backup from iTunes 10.3.1. And here is the code right here. It's 1234. Now, I know you're thinking that, hey, that's a very simple code, and it took 10 minutes and 6 seconds to crack that. Just keep in mind that I am using extremely old equipment from 2012. It's a laptop, for crying out loud, of a Mac. The graphics card is aging. But if you want some tips on how to build up a Hashcat machine, there are tons of them out there on the internet, or just reach out to me. I'll explain some of the components that you may need in order to do that. So there you have it. Just proof that Hashcat can indeed crack encrypted backups from iOS 9 and iOS 10.